The goal of these set of videos, which I'm going to present, is basically to think out loud. Now, these videos are based on the premise. In fact, one of the premises is how to think, which was a topic of my previous video. And these set of videos are based on that premise of thinking visual. Now, there are various challenges that are facing the world today, and I am interested in engaging people who are interested in STEM fields and may or may not have chosen STEM field as a career. However, they are interested in diverse ways of thinking because I feel that the key to finding solutions to challenges facing this planet is to have great ideas, and great ideas come from deep thinking, and then these ideas can be tested out using scientific methods in the field. So I will illustrate this with an example, and the challenge that I am addressing today is the question, how do tumors form? Now, I am taking the approach of not going into papers, but an observational approach. The thing is that we have all seen on the internet, and people who are in the medical profession have seen tumors, and they usually appear like this tight, condensed mass or like a blob. Now, based on this observation, the musing is as follows, is that when we observe a photograph of a tumor, we see that it is like this jelly-like thing, and it appears like this very irregular in shape. And as for students who are in the field of tumor biology, they will be told it's an uncontrolled growth of cells which form a mass. So the observation leads us to this kind of musing that a tumor is like a condensate or a condensed mass of cells. Now, the analogy that I'm going to draw to real life is that this is similar to the formation of a precipitate from solution. So for example, on the left side of the slide, you can see a solution, and this is where all the particles have interacted with water and have kind of completely melted into the water. While in the middle is what is called the particles are visible individually, but then they slowly start kind of aggregating or coagulating or mixing with each other, and they precipitate. So in this way, somehow in the middle what we see is the abdomen, which is a system of organized tissues or organs, and each one having their specific role. And on the right side is a tumor mass. So a tumor is what initiates the process of cancer, which has two parts, the formation of a tumor and the spread of the tumor to the distant parts. So if you compare the left side, where the abdomen is showing organization of organs, abdominal tumor mass is like this irregular, mushy, slushy mass of tissue. And so the main difference we see is this lack of organization. Now, in a tissue, there are individual cells which have different functions, and they are specialized, and they are arranged in a specific way. This loss of organization is what happens during the formation of a tumor. So when I was using the analogy of precipitation, it is like these organized cells which were arranged in a specific way somehow lose their interactions with each other as a part of that organ system and come together and form this loose mass of cells. This loss of definitive interactions is what scientists technically term epithelial to mesenchymal transition. Briefly, I will say epithelial cells are these very specific cells which have, polarity. That is, they have a surface, a certain surface which is called the apical surface and a basal surface, and they lose their structure and become elongated and go into the blood and spread to distant sites where they form a secondary tumor. So the idea in this case is to think of a tumor as originating from organization and then going back to this very disorganized state. And when I compare it to a precipitate, it is like these individual cells in the center which are occupying specific places in the solution, and they're coming together to coagulate to form a precipitate. So I would like the viewers, or basically the listeners, to think about this analogy and find out, if you're specifically in the field of tumor biology at the master's level or beyond that, how this kind of disruption of organization occurs. Is this basically intrinsic? Maybe there are genetic factors, or is it catalyzed or stimulated by environmental factors like viruses? And so if you draw it out or try to think visually, maybe you can come up with new ideas. The details of the technical details of all at what is happening at the molecular level, you can go to PubMed and find out what are the players. But the big idea in this case is loss of organization, where cells lose their specific, you can say, niches or habitats, and they just coalesce to form this group of, irregular blob or mush, which has uncontrolled growth or proliferation. I hope you enjoyed this video, and please do write in the comments whether this thinking visual is able to engage you in thinking about not only the issue of disease, but also other challenges facing the planet today.